then move to the transformation part. Right? The basic transformation, the idea of the basic transformation I gave you last time. And I showed you how to do a specific like major transformation using this identimetry in 2 by 2, 1 0 0 1. This point, let it be P1 and this is P2, right? I'm looking at this problem. This is 1, right? 1 0, this point, right? And this point is 0 1, this is P2, right? P2, right? P1 and P2, right? If you need to rotate it, is of course P1 and this P2, right? If you need to rotate it, right? Let's say it's a reflection. The reflection into the y axis, right? Reflection into the y axis. When you turn it into the other way, P2 remains as it is, and this is going to be into the other way, which is P1, which is negative 1, 0.
Take the
Yes.
sign of the y.
Yeah, because that's a reflection into y-axis. You know the reflection metric, I derived that last time, but the derivation is not even because this is in the formula sheet, right? Do you remember this?
Yes, boss.
Sin 2 alpha, sin 2 alpha. This is a reflection into what? Reflection into
Y.
y equals tan alpha x.
Nice.
Tan alpha is a gradient. So this time tan alpha becomes, then alpha becomes 90 degrees, right? Then it is the y-axis. When alpha becomes 90, it becomes y-axis. Alpha becomes 90. Then alpha goes to 90. Then alpha is exactly equal to 90. This becomes cos 180, sin 180, sin 180, negative cos 180. Cos 180 is negative 1, and this is 0, 0, this is negative 1 plus 1. Finally, this becomes negative 1, 0, 0, negative 1. Look at this. When this is transformed, this P1 point goes to the other side, so it means that coordinate is negative 1, 0. This coordinate is as it is in the same way 0, 1. Look at this, make it the same. Right? For specific types, P1 is going to be reflected in the other way, minus 1, 0. This is minus 1, 0.
So it's basically a multiplication by that.
Yeah. We got the same reflection metric using even the general format. Even using general format, this can be used generally, but if you have like specific axis like y-axis, x-axis, those type of specific thing, then you can depend on the identity metric. Okay. So how the identity metric works, how the identity metric responses on that, then it gives the same. Right? It gives the same. So if you need to reflect any other point, let's say 2, 1, then this point is registered as this vector of this point is, or Q is 2, 1, and that is quantified by this. And if it is the metric, a transformation M followed by N, it is nothing as N into L. M followed by N. N is multiplied by N. rotation metric. The rotation metric is remember that cos theta is negative sin theta is seen, right? This is rotation metric. Rotation metric about the origin, anti-clockwise by 90, by theta degrees, theta angle, right? And it is the opening in ring. The derivation of that is upper x equals little x cosine theta and little y see the other way. This way we have been projection in the other direction. Little y this way means the other direction means little y sin theta. And upper y equals this is plus, but these angles are going to switch the coordinate direction and use the direction I used. So this should be appended on this. Little x equals upper x cosine theta, little x equals negative upper y sin theta. Then little y equals little y equals upper x sin theta plus upper y cosine theta. So then the transformation metric is cosine theta negative sin theta plus cosine theta is fine. This is given in your formula sheet, right? So when you find this rotated clockwise, so then anti-clockwise theta is replaced with negative theta in the other way. So this is from x to upper x from little x and upper y to little y. If you need it from little x to little y, we can multiply both sides by the inverse metric of this. Otherwise, we can derive it in that way. If we multiply both sides by the inverse metric, what is the inverse metric of this? Cosine square theta minus sin square theta, which is 1, right? It's 1 over 1. So what's the inverse metric? So when this is multiplied by the inverse metric, let's call this rotation metric, and it is multiplied by inverse metric. Upper x, upper y is going to be subjected. Right? This is the inverse metric. This is the inverse metric. Inverse metric. So this is going to be identity. It's going to be identity. Identity into any metric is it's same. That the same vector. Same vector. So this is 1. Then cosine theta. Cosine theta. Sine is switched. Sin theta, negative sin theta. If you want to go from here to there, we can use this. The other one. Right. Right. Shall we start it now? Minus square root of 3 over 2 minus half plus half minus square root of 3 over 2. Then determine the a square is not too hard. So metric multiplication didn't do that. You did it again.
Yes.
Half minus square root of 3 over 2 minus square root of 3 over 2 minus half minus square root of 3 over 2. Right. So if you wanted to do it easily, you could take out half, and it's going to be 1/4, right? It doesn't matter. Here, this one, negative 3 over 4, this one, negative 1 over 4, negative 4 over 4, which is negative 1. Isn't it? Right? And this one, positive, and this is positive. Both are positive, and the square root of 3, isn't it? Minus, right? Minus root 3, minus plus 3 minus 1. So you got half.
Yes, half. Yeah. Minus what?
So what is it? 3 over 4. Oh my god. Oh my god. It's wrong. It's wrong. 3 over 4 minus 1. Then it's half. Yeah, it's half. Then this is plus 3. This is plus a square root of 3 plus a square root of 3. Then there is the square root of 3 over 2, isn't it? Right? This is minus square root of 3 over 2. Then this is minus 1/4 plus 3 minus 1 is 2. And now the x cancel off. This is the answer. This is the answer. Correct. Describe for a single geometrical transformation represented by by the matrix A square. What is it? A square. This side, only this side is changed. It should be a rotation. When we check these elements in this base diagonal, in this main diagonal and second diagonal, these elements are equal, and one of the side is changed. It means it could be a reflection or a rotation. Right? Reflection or rotation. If it's a reflection into y equals tan alpha x, it should be cos 2 alpha in this format. Negative cos 2 alpha, but the sign is not changing through the main diagonal. It's changed through the second diagonal, so therefore it should be a rotation about the y-axis, sorry, about the origin anti-clockwise by theta, right? So it's a rotation. Negative sine theta equals square root of 3 over 2. Right? Then cos is positive and sine is negative. Could be in the fourth quadrant. Cos is positive and sine is negative, isn't it? Is in fourth quadrant. Theta can be negative pi over 3, isn't it? Negative pi over 3. Yeah, it's 2 pi minus pi over 3. That's it.
2 4.
Yeah, it's 2 pi minus 2 4 means 2 4 degrees. 2 4. Degrees then. What is it? 360 minus 60. It's 300. Should be 300.
180 minus 5.
180 minus pi over 3. Pi minus pi over 3. No, the sign is positive in the second quadrant. You are talking about pi plus? Pi plus 180 plus 60.
No, 180 minus 60.
Minus 60 is positive. The sign value is going to be positive. In the second quadrant, sign value is positive. This is first quadrant, and this is second quadrant, against third quadrant, and this is fourth quadrant. Isn't it? And here, look at this. Sign should be negative, and cos should be positive. You have to consider both. Yeah, both should be considered. So that's why we can't count the third quadrant, right? The third quadrant can't be counted. Because the sign is positive, but the cosine also is positive in third quadrant because of x, the projections on the x and y axis.
So
Both are negative.
So it's a rotation anti-clockwise.
It's a rotation. We can describe it same in two different ways. Anti-clockwise, 300 degrees clockwise, 60 degrees above the origin. Both are revealing the same idea. You could rotate either 60 degrees clockwise, so pi over 3, since it's negative pi over 3, is this way, right? It's rotated above the origin. Rotation about the origin by pi over 3, radians clockwise. This is right. Otherwise, rotation anti-clockwise about the origin by 2 pi minus pi over 3. 2 pi minus pi over 3, which is 5 pi over 3. This is right. It's really great.
Yes. Which means?
Yeah.
Are you sure?
Yeah. Normally, these days there's no regular constantly wait until exams are ended.
Beta is the smallest integer value of which a to the power n is an identity.
Yeah, that's quite challenging one, but
That's one more.
it's a pi. It's only 1 mark. Right. It's a to the power n is identity. Once again, how it becomes as going to be. Identity means this is 4 coordinate. If you started with this one, this is a square, isn't it? Hence determine. It means using this one. Using this one, we are supposed to determine this. Identity means it's fallen into what? It's fallen into 1 0 0 1. So how many times we have rotated?
677.
The rotation. So now the point is this one. This one is the point. This is the point. When we multiply that point by, if this is the point, when we multiply that point by this transform metric, it's going to be rotation like this. So when it's going to be appended here. In rotation. How many times? Shall we consider that?
You have to do it manually.
Yeah, the normally show learning because here look at this. This is very easy. One second, I'll show. First, look at this point. When we place on that point, what's it, minus square root of 3 over 2. 3 over 2. And plus half this point. I will place on this point. Then plus half. Plus half is this was 30. 30. This looks like 30. This is okay. It's not required. I'm giving it again 3. 30. Then this is half, right? An initial point. Then what's the other one? It's negative half. Negative half. Negative square root of 3 over 2. Negative half. Negative square root of 3 over 2. Right. This is 60 degrees. Right. So let's call this P1 P2. This is P1 P2. Now there should be appended 1 1 0 0 1. This is the identity metric, right? Are you okay with that part? Then here I'm going to rotate this one. Then our destination is here, right? Our destination is this point. This one is our destination. Let's call this Q1. This is this is Q1. This is Q1 and this is Q2. Right? This is Q2. It is 0 1. 1 0 0 1. That's the destination, right? Look at this. Now this is going to be rotated, right? Now this is going to be rotated. using this metric. What is this metric? Rotation metric.
So what's
It's
your answer?
about, is it what? How many times it is?
I just checked my answer.
Yeah, okay, let's check. Okay, let's check. Let's check. This is when the rotation is applied. How many times? Let's check. When this is rotated 60 degrees, 60 degrees clockwise, we are supposed to rotate clockwise, right? Clockwise, a square it becomes this. This way. Is it the answer? No. One more time. Right? Like that, we have to count until this P1 appended on Q1. Right? P1 appended on Q1, and we can easily calculate that what's the difference between them. How many 60s are there until it comes to this position? How many 60s are there? This is the rotational angle.
8.
Yeah, this is the rotation angle. How do we calculate that? It's 360 plus 60. How many 60s are there? 6, 7. 7. 7. 7. 60s. 7 60s. When it comes to that position once again. After one complete rotation outward. So this is Q2. It should come to this position. This is Q2, right? It should come to this position. It means another 90. Another 90 is added. Isn't it? Right? Is it correct? Let's check. When it comes to this position, it is 360. 60 plus 90. 60 plus 90. So the rotation is by 60 degrees, right? Can't we divide it by 60 exactly?
No, 9.5.
Then it should go one more cycle.
It's already there. Q.
When it is rotated clockwise 60 degrees comes to this position. One more time this position. Right. This is 1, this is 2. One more time here. 3. Right. One more time. You see 60 now. 60 now. 60 now. This is 30. 60 now. It's here now. 30, 30. It's here now. It's fourth term. And then fifth term it's here exactly. Right. Sixth term it's here exactly. Right. 60. Then seventh term it is here. Seventh term it is here. 30. Eighth term is there. Eighth term is here. Right.
Yes. That makes sense.
Eighth term is there.
It's not 8.
It's not 8. It's not 8. We applied this transformation 8 times. We have calculated based on that. 8 squared. 8 squared is the transformation. It is applied how many times? For that base 1. 8 times. Then 8 times means this is applied 8 times means if it is applied on this one time, it's going to be it is coming to this position. Right? If it is applied on that once again, a square. It's applied on that once again, a square. If it is applied 4 times, a square. Right? If it is applied 5 times here, a square. If it is applied 6 times, it's here. Again, it's multiplied by a square. The 7 times. No need to do this repeat. I'm giving you the idea, right? We can the difference between this angle and how many 60s are there. Using that we can manage it. Again, how many? How many is? Right? No, no need to. 2, 4, 6, 8, 10, 12, 14, 16, 17. 17. 17. It means 17. If somebody tries to do that manually or using calculator,
It is not 70.
they will get that tomorrow.
It is 12.
So,
It is 12.
is it?
Yes.
How is it going to be good?
Yes, it's
Is it?
very, very good.
Is it something wrong? It's okay. 30 half. The angle is there, this is 30. When it's rotated one time, it's here, another time it's here, another time it's there, another time it's here, another time it's here, another time it's here, here. Each of every time that should be one time. It should come to this position. Come to this position. How many are there? 3, 6, 7, 8, 16, 17. I got 17. What's before that doesn't eat. Rotation is correct. When this set is rotated clockwise, comes in this position. Clockwise, it comes in this position. Clockwise, it comes in this position. It's here. It's there. Exactly, it's here. It's here. Is here, another 60 is here, another 60 is there. How many times we have rotated? We explain this metric or this A square metric? Oh, we explain this metric, right? We explain that fully describe this A metric A. Is multiplied by A, so A square. Is it 3, 9, 6, 9? What's wrong with it? We got this one. This one is half. What's the described metric here? The rotation metric? This one, right? This one. We will describe this one.
Yes.
This one.
Yes.
This one. We will explain. And we apply it on. only this point, we'll check the other point as well. Sometimes if it doesn't come to this point, we can't do it with that. Right? So we have to apply it for this one. That can be sometimes even number. We have to check the other point as well. We have to check the other point as well. Then we'll check that here. What's the difference here? We should come to this position means rotation is rotated by what's the angle? This is 150 plus 360. It won't be affected from that. So we can't start it with this A. Why? Because here this angle is 150.
Yeah.
Right? This angle is 150. If you should come to this position once again, if it is within 150, then won't be able, because 60 times that's not exactly divisible. Right? It's not exactly divisible. So it's not going to be an integer. Right? So therefore, we can work with this one. This A squared. So it can be even without being 1. If we apply it for this A, what happens? It's always is going to be like A cube, A to the power 5. Those things, why it doesn't work? Because that's not divisible. Since it's not divisible, we will try to apply it on by considering this as the base point. We will start A squared like this. Right? A squared is half. It is half. Negative square of 3 over 2. It's negative square of 3 over 2. Negative square of 3 over 2. This one. And the other one is this is negative 60. Isn't it?
6.
Yeah. Then what is this one? The square of 3 over 2. Then half is this way. This is half this way. This is 30. This is 30. 90. Right. This is our first point P1. Right. And call this our base point P1, P2. That should happen on Q1, which is Q1 is here, right? Q1 is here. Exactly is here, right? Q1. So how many? What's the angle? Rotation angle. What is this angle? 360 minus 60. Isn't it? 360 minus 60.
Yeah.
Right? 360 minus 60. It should be rotated. How many 60s are there?
5.
Yeah, it is 5. Right? It means on this base, we have to apply it 5 times. 5 times, when it's going to be applied 5 times, you can imagine A to the power A squared to the power 5. That effect is an S. 5 times. So then A to the power 10 into 2, which is A to the power 12. So last time then I was trying to rotate it actually without based on the calculation. Could you understand that? Right? So there's no point of depending on this point, right? And even they have given the ends, then we could simply go through A squared. So there are 2 possibilities. And since there are 2 possibilities, we start with this fundamental. This one by keeping this as a base point, but it's not the way, right? It's not the way. Because could you understand first? Sure. Because if we start with A, we get only even powers, right? But even that can be odd power. So we get only odd powers. We won't get even powers, right? So if we need to get even powers, we have started with A squared. So that was a very easy question. We took What I in way, right?
Good.
Not good.
The matrix B represents a stretch scale factor for
Yeah.
parallel to the x-axis. So
With the x-axis, it affects on this A, then this is 0, 0, no no stretch is applied along the y-axis.
yeah, x-axis.
X-axis.
No. Parallel to the x-axis.
Parallel to the x-axis will be 0, right? This is
So how?
Yeah.
How so?
How? Yeah, it is this way, right? Let's say xy, when you apply that, it affects only a, it affects only x. This won't be changed. This is 0, right? And this is 0. That won't affect on the x here, right? This is y. You can see now. Only this x coordinate is multiplied by a, but y coordinate is not changed. The stretch scalar factor is applied for only along the x-axis. Right? So we have solved this. Did you finish? Could you understand?
Yes.
In your previous question, you understood that.
Okay. The transformation represented by matrix A followed by the transformation represented by B.
Yeah. Matrix A followed by B.
Is represented by C. Zero.
Yeah, there's B times A equals C.
B is
Because A followed by B.
B.
Then on P, we have to apply. A is followed by B. A is followed by B. So last time we were trying to depend on this one, right? And that's not the base coordinate, right? That's not the base coordinate. This time, the parallelogram is transformed into B dash philologic metric C, transform metric C, then C to P is P dash, the area of P into determinant of the metric transformation C is equal to the area of P dash, which is 20 is divided by determinant C. Then we were supposed to find the area of the parallelogram P is the base parallelogram. But then structure. Right, the challenge structure. Using the induction for positive integers, we are supposed to show that m to the power in this transformation. It's basically a rotation around about the origin anti-clockwise by theta. Then if it is applied n times, I will show that this is correct. Right. when n equals 1, when n equals 1, m to the power 1 is cosine theta, negative sine theta, sine theta, cosine theta is correct. The rotation metric is correct, and expression is correct, right? Then let's assume that for n equals k, where k is a positive integer, the rotation expression is true. Further, m to the power k cos k theta negative sin k theta. This is sin k theta. This is cos k theta. Right? Then we are supposed to show it's true for n equals k plus 1 as well. Then for this one, this is the assumption. Label this as the assumption. We can split this into two metric multiplication into the power k. Then as per the assumption, n to the power k is cos k theta negative sin k theta. We'll do it quickly without taking too much time, right? This is cosine theta negative sin theta. Did you do that?
Wait.
I didn't, right? This row into this column, which is cos k theta minus sin k theta sin theta. This row, this column, negative sin theta cos k theta, negative, that sign is taken out completely, sin k theta cos theta. This row into this column, sin k theta cos theta plus sin theta cos k theta. This is negative sin, it's here, negative sin theta sin k theta. This one is here cos theta cos k theta. These are nothing else. Cos k theta plus theta, which is k plus 1 theta, and this is negative sin k plus 1 into theta, right? This is the expansion of sin k plus 1 theta, and this is the expansion of cos k plus 1 theta. Is it fine? Oh, you can learn it. Alright, okay, so you can, I can give you the class to do, right? Today we will do like a revision quickly. Like a revision quickly.
Can we do the paper that we did last week? The MCQ piece?
We will complete it.
Put your collar properly. Rowdy one. I don't break up with the you should do it. It's fine. Is it carbonated? Sparkling. Thank you. I just kidding. What for me?
No.
Then I'm just kidding.
I'll share the email. You have CGP with you.
No, so give it to me.
And you can
You sent it, right?
yeah, I have said it earlier. Then I will say it once again. Wait.